Okay. How are we doing? Okay. We're doing okay, I hope. All right. So I wanted to talk about the midterm for this class. I was debating on how things should be done. I've decided to take a risk and make it an open-ended report project analysis type thing. Okay. So I'm gonna download it right here, and let's save this file. So it's posted up online, and let's look at this. Okay, so forgive me, but I've decided to use a baseball data set. And so I know some of you have no interest in baseball or are rather unfamiliar with baseball. That said, I think the database kind of fits the criteria of being big enough to be interesting, where multiple approaches can be, like, people can do different things that are creative, but also not so big that it's overwhelming. Okay, so it kind of hits, in my feel, a sweet spot in terms of the amount of data that is there. So I'm not just giving you like a little table with 2 columns and say analyze this, where there's only one way to analyze it. This guy Sean Layman, he's created this, and what you're gonna do is you're gonna just click this comma delimited version here. You're gonna just download it. Okay, you're gonna save it somewhere, and where does it save for me? It saves. Okay, so you're gonna unzip this wherever it is. So we'll click extract all, and so maybe I'll just put it on my desktop here. Oh, I put it right on top of the desktop here. So let's create a folder here. Okay, so I'm just gonna call this midterm, and so just put all of these CSV files into a folder, and then put the R markdown file that we're going to use, put that into the same folder. Okay, and that way you can reference the tables in the Laman database without any file paths. Okay, because when you include file paths in your R markdown file, it just makes the rendering and things for someone else's computer like impossible. Okay, but if we say this is how the files are going to be arranged, that the data files are in this folder, and the R markdown file is also in the same folder, then everything will render fine. So no paths, just call the tables directly. Okay. So baseball is a sport, you know, and baseball, they've been keeping baseball statistics for a very long time. So in terms of just statistics on sports, baseball has kind of one of the biggest records and things like that. And so we can open up any of these tables. So something like batting.csv, this carries a whole bunch of information for batters dating all the way back to 1871. Okay, coming, you know, to last season, 2014. So the 2015 season just ended, like I don't know, yeah, just like a few days ago with the World Series, Kansas City winning the World Series. So that data for 2015 has not been entered, but up through 2014. Okay, and you can see, so these are just different players. They're hard to the players have all been kind of abbreviated using this funny system, and we'll talk about this. Okay, this the next column shows you the year. So let me where's freeze panes, freeze the top row here. Okay, so we have things like the year of this information. They have something called stint. Okay, so sometimes a player starts on one team and then they get traded or moved to another team, and that's kept track also here. So the first team that they start out on, so is the first one, and then the second team will show up as stint 2. Most players are just going to have only one number in stint, but if a player gets moved around a lot, this guy has you know, 3 stints and things like that. Okay, so sometimes that happens. The Major League Baseball is split into 2 leagues. There's the National League and the American League. Okay, so teams like the Yankees and the Red Sox, I don't know if you've heard of these teams. They're big teams. They play for the American League. Teams like the Los Angeles Dodgers and the San Francisco Giants play for the National League. Okay, and so half of the teams are in the National League, half of the teams are in the American League. And most of the games are within the same league. So most of the time, American League teams play against other American League teams. Most of the time, National League teams play against National League teams. Every now and then, they play teams from the other league. And on the batting table, it keeps track of just different things. And you see, you know, the columns are these slightly cryptic. Unless you're into baseball statistics, they're a little bit cryptic. And it just says G, which represent games, and AB for at-bats and all of this stuff. And it keeps track of all of these different statistics that exist. And these are season totals, okay? So this is the total number of games a player played in during the entire season, things like that, okay? The seasons, there are 162 games in a regular season of baseball, okay? And so the number you see here should the biggest number you see should be 162. If they continue on in the postseason, so after the regular season is over, they have kind of like this championship bracket, okay, where teams play against each other and they move on, and if they win, then they are crowned the World Series champion, and you know they have to play more games for that. But usually, you know, only 8 teams move on to that. So out of the 30, only, well, I guess with the wild card, 10 teams. But anyway, we keep track of all of every player and how often they show up, and you know, some players don't play very often, some players play a lot, and things like that. Okay, this is all kept track of in the batting table, and if you don't know anything about baseball, you should still be able to do this project just fine. Okay, there is a Readme file, and it seems huge. Well, it is kind of a long file, and it just explains every single table. Okay, so there's all these tables. There's the master table, the batting table, the pitching table. So these are probably the big tables here that are most important, and then all of these kind of include little other bits of information that might be useful depending on what it is that you're trying to analyze. So I recommend going through, just kind of scrolling down until you get to the description of each thing. So when you open up the master table, the column headings will be these different things, and it'll say, you know, the month, you know, when the player was born. Because these contain records from dating back to 1871, it also keeps track of when players have died and things like that. The player's height and weight when they were playing, their official stats, and things like that. Okay, and this takes their first name and last name and things like that into a player ID, because you know there might be multiple players named, you know, John Williams or something like that, And so you have like John Williams 01, Williams 02, 03, and things like that to keep track of players with similar names. Okay, and so here, the batting table lists off, okay, G is games, AB is at-bats, R is runs, and all of this stuff. Now, some of these things, especially if you're not familiar, you might be like, what is a sacrifice fly? Okay, or what is a sacrifice hit? All of these things, you can just go to Google and you just type in wiki, all right, baseball, you know, sacrifice hit, okay, and things will pop up here, okay. I think Wikipedia is an excellent resource for these types of things. So you got sac fly, sacrifice bunt, also called the sacrifice hit, and it says it's a batter's act of deliberately bunting the ball before there are 2 outs in a manner that allows a runner on base to advance another base. Things like that. So, you know, these are things that they keep track of in baseball. Like, so oftentimes something like this happens when a pitcher, because pitchers are known for throwing the ball, they're not known for being good hitters. So sometimes they'll just purposely just try to tap the ball, knowing that they're going to get out, because they weren't expecting to get on base. But by tapping the ball, it gives the chance of the other people on base to try to move forward into scoring position or something like that. You know, if you don't watch baseball, that's okay. If you watch a lot of baseball, I think if you watch, I'd say more than just a couple games of baseball, you start to appreciate there's a lot of kind of strategy in terms of knowing what your players are capable of and the things that you want them to be doing, right? So do you want someone to try to steal base? All of these things, okay? So anyway, you've got all these tables to deal with, and for the midterm, what I want you to do is let's view this here. Okay. I just want you to ask a statistical question. So I would say start by first looking at the table descriptions. See what kind of data exists in the table descriptions. So, and then just thinking of looking at the type of data that exists in the table, I want you to ask yourself a statistical question that can be explored. All right. So just, you know, and if you're having trouble coming up with a statistical question, you know, I gave you a few examples here to start with, but, you know, I would be excited to see what kind of questions you guys come up with and what kind of explorations you come up with. I'm not expecting you to come up with a definitive answer for these things, okay? This is a lot of times data, you're not going to be able to come to definitive conclusions. A lot of these questions are you know, kind of impossible to answer also. But here, you know, here are some examples. Okay, there's a salaries table that keeps track of how much each player is paid. So we can say, you know, what variables influence a player's salary. Okay, so you're going to try to keep track of things like their age and their performance and how many years they've been in the league and things like that. Or, you know, does a team or a player's regular season performance predict how well the team or player does in the postseason? Has batting or pitching performance changed over the course of time? How does a player's age affect performance? Is the effect of age different for pitchers? What combination of statistics can predict a team's win record? Or how well does a player's performance in one year predict his performance the following year? These are just examples. I would love for you to go through the descriptions and try to come up with another question or something that can be explored. One thing to note is that these only contain season by season statistics. We don't this database does not contain information on individual games. So you cannot go in and say, you won't be able to answer questions like, does a player do well? If a player had an amazing game performance one day, does that give him momentum to do well the next game or something like that? You can't answer those questions because these are just from season to season, okay? Are there any questions so far? No? Okay. I've linked a little video on baseball rules, it's kind of a fun video. He uses a whiteboard to draw all of this stuff. He's going really fast, is that right? Yeah, that's normal. And he's talking this whole time, so 162 games. So it's a good video. Other reliable sources of information, so I said Wikipedia is great, but these other places are also good. One thing to keep in mind is that the tables all contain what's known as counting statistics. Okay, so we keep track of the tables will tell you the total number of games the player has played in, so that we're just counting how many games the player played in. We count how many times the player scored a run. Okay, which is how we keep track of points in baseball. We don't say points, we say runs. Okay, how many triples the player scored, things like that. There are other statistics. Maybe you have heard of the statistic batting average. Okay. Batting average is calculated by doing the number of hits divided by the number of at-bats. You will not find a batting average value in the batting table. Okay, even though it's calculated from the values in here, there's no statistics here that are based on combining variables. So here, if you want to calculate batting average, you're going to have to do what? Mutate and dplyr. Okay, mutate and dplyr combines different columns and things like that. Okay. So anyway, so these things exist. There is a whole field, and I considered trying to. Well, I did apply for a job with the Dodgers to be on their Sabermetrics team. I didn't get the job. I ended up here, but I'm super happy to be here too. This is my dream job, and the Dodgers would have been another dream job. The opportunity came up, and I thought, wow, that would be a lot of fun. But there's a whole nother there's a field called Sabermetrics, and it's all about taking these things and trying to predict player performance, team performance, things like that. If you ever watched the movie Moneyball, kind of touches on the topic of sabermetrics, and it was about the Oakland athletics manager who saw the potential for sabermetrics to pick out a team at a budget price, things like that. So for example, they combine all of these different columns in the batting table and say this gives you weighted on-base average, which when you calculate these statistics, this correlates incredibly highly with how many runs a player or a team will score. So if you're interested in possibly calculating stuff like this, you can find out a lot at this website called Fangraphs. I'll be honest, it can be a little overwhelming the first time you visit. I would say if you're gonna the first time you go, just click Getting Started, and you can read through this, and it talks about all of this stuff here. Okay, but it might be too much all at once. Okay. when you're going to get the data into R, I've given you some code in terms of reading it in nicely. I think library reader helps. Okay, so let me clear out my environment here. So this is in the file here. So we load up library reader, and so this means I'm going to use read underscore CSV as the function to read in our data. And so I just type in the file name because this exists in the same folder. Or actually, I have to do source file location, and then you know, column names are true. What's important for read CSV, the defaults are very good, but because it's designed for efficiency, it does some things that will throw off our batting data table. Okay, and so when you if you look at the batting data table, the source, you see you know, we didn't collect information on things like sacrifice hits and sacrifice flies until recently. So all of this data is missing for these players from the 1870s. Okay. And so for these players, or for those things, we're going to say the NA string is just nothing. If there's nothing there, it's missing. And then we have to say, but expect, you know, integer values for these columns. Because when read.csv, if you don't specify the types, read.csv or read underscore CSV is going to see all this missing data and just say, oh, I'm expecting logical values or something like that. Okay, so by using like this, we read it in and it reads it in very quickly. Okay, there's almost 100,000 observations here, but it goes in quickly, and then we can ask for the structure, and we can see this is exactly as we would expect it to be. I'm not expecting you to do an analysis on the entire history of baseball. If you want to, you can. Okay, if you want to, that option is available to you. If you want to just say, let's look at baseball data from the year 2000 and on, totally fine. If you want to say, hey, you know, I'm curious about when Babe Ruth played baseball, you know, back in the 19 whatever. Okay, you can find out that information. If you want to zero in on just pitchers, fine. You can do a comparison between, you know, how do shortstop players compare to outfielders in their batting performance. Okay, so, you know, if even if you don't know anything about the game of baseball, okay, there's just a lot. You can just kind of just see what variables correlate, what variables might be of interest. Okay, I would much rather you ask one interesting question and explore that as much as you can than try to ask like multiple questions and just do a lame, here's a model that I fit and that's it. Okay, you know, kind of document your entire thinking journey here. So say, I'm curious about this. I'm going to start looking at this variable and this variable, see how it relates. I've tried fitting a model and it looked like this. Doesn't seem like a great fit, so I'm going to try adding a variable or taking away a variable. I'm going to try transforming a variable and see what effect it has. I've also included just a little bit of code here for combining tables. So there's a whole bunch of tables, and you know, if you want to do an analysis based on batting performance and salaries, okay, then you're going to have to merge those tables together. And so dplyr allows for that. Look up help on dplyr join. And oops, I gotta load dplyr first, and then you can ask for help here, and it shows things like inner join and left join and right join and all of that stuff. Okay. So these are kind of SQL terms, but these show you how to knit tables together. You can use this if you want to do group by and summarize the data first before you fit the model. It's also fine. Okay, so you can try to kind of create summary, so you can do a data analysis on the batting table data directly. You can also do like group by player ID and do a sum and get like the total batting numbers, right? So like over a player's entire career type of thing, and do some analysis there. If you're going to do something for an entire player's career, you're probably going to have to look at slightly older data, because if you look at data from current years, chances are they're still active players and things like that. So do you have any questions? Yes?
If you scroll to the top, you said column something CIII. What does that mean?
Oh, okay. So this is a shorthand to say the first column has character data, the next column has integer data, third column is integer, fourth column is character, integer, things like that. Okay. If you want to say this is the third column has double, you would do a D or a L for logical or something like that. This is all detailed in read_CSV under arguments for column types. It gives you things, but it'll say double, integer, logical, and character, and you can even do an underscore to skip a column in the import process, but you probably don't need to do that. So read_CSV is part of the readr package. Okay, read.csv is part of the base package. Okay, so if you don't add any libraries, read.csv exists and it reads data in from a CSV file. Read_CSV comes in with the readr package, so you have to install this library and that. Read_CSV, the performance is faster, so with large data files it reads data in faster. It also it defaults to not turning in character data into factors, whereas read.csv defaults into turning character data into factors, which can be annoying. So for small data files, read.csv is totally fine, but once you get over like 10,000 observations, usually read_CSV, it's worth loading the library and using read_CSV for reading in data. Yeah, so I hope the project or the assignment is interesting. If you're unsure about anything, don't hesitate to ask questions. I'll make myself available on Piazza from now until Monday when it's due. You can start taking a look at it, and so yeah, feel free to look around online. Feel free to go on Piazza. I just asked don't talk to each other about your data analysis, but the conversation on Piazza is open, and so you can if you want to kind of just bounce ideas off of me and Piazza, or just if you're having trouble with a certain task, like you're trying to merge data or something, or merge tables, you can ask those questions here. So, yes. It'll be due Monday, yes.
Just curious, how big is the data file?
The data file zipped up. 8 megabytes, 8.5 megabytes. So it's not crazy big, but it's not a tiny thing either. Okay. And yeah, there were much bigger data sets, and I was just kind of debating how much. So yes.
In our explanation, like I know it's always good to really like explain why you're doing everything you're doing, but
yeah.
Like to what extent do we need to explain things that we've learned in class that like we've learned, like what everything means like to someone who doesn't know about statistics?
No, I guess. Yeah, you can assume that it'll be read by someone who's knowledgeable, so you don't have to explain least squares regression tries to minimize the squares of the residuals or something like that. But I guess explain your decision making. If you say, if you choose to remove a data point, an outlier in your data, explain why. Or if you choose to transform your data, say, because of this reason, I'm going to transform my data. It shouldn't just be arbitrary. Here, I'm going to just whatever, okay? I mean, sometimes that happens. Sometimes you say, well, I don't know what to do, so I'm going to just try something and see what works. Sometimes that is part of data analysis, but try to explain your decisions, and I would say that's good. You know, and because this is baseball data based on real things, if you find an outlier, a lot of times it's like a player who is really good, right? So if you find a player with a ton of home runs or something, that could be Barry Bonds or something, you know, player who, or Hank Aaron, or, you know, just all these kind of quote baseball legends or something. And so as you're exploring your data, you find an outlier. It might be worth looking in, seeing the corresponding player ID and looking up that player ID in the master table, which has their full name, and then just doing a Wikipedia search on that person and seeing, why is this player so interesting? And then they might say, oh, so-and-so is amazing because, you know, Hall of Fame, blah, 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 stuff like that. So usually outliers in this data set are actually interesting, and you can look up and think, rather than just saying, well, here's an outlier and we don't know anything about it, we'll try removing it just to see if our data fits better. Okay. Yes, another question.
Is there a format we should follow for our report, like introductions?
Well, yeah, I mean, so you should start off with, here's the statistical question that I'm interested in, that I want to explore, and then I would say the rest of your report will just be kind of explaining your process. And then if you come to a conclusion, write your conclusion at the end. If you come to a non-conclusion, saying, I did all of this exploration, and at the end of the day, I have no idea how salary is determined. It just seems kind of crazy that some players get a lot and some players don't. I don't think the answer is there's no reason behind player salary, but it might be, you know, batting performance plays into it, but just there's a bunch that's unaccounted for also. So I would say, yeah, your report should explain your process, the things you've explored, and then at the end, if you can make a conclusion, do so, or summarize what you found. So I'll be grading based on your thought process and kind of the legitimacy of the analysis that you've done. So you should know whether the model you fit is decent or not, whether, you know, no model is going to be perfect, okay? That's another important thing. When you fit models, none of them are going to be perfect, so you should point out the deficiencies of your model, but maybe you can still use it to make predictions or judgments. Yes?
Is there a way to resize graphics in R Markdown so that, you know, like a lot of graphs one after another, they're not just taking up a lot of space?
Yes, and I always forget the command. It's like figure size in R Markdown. Let's see. How to set size for plot size and so it looks like figure.width and figure.height in the code section where you're generating it. You can post this on post your question on Piazza, and I'll try to answer it. But yeah, if we're trying to resize graphs, that's fine. But you're not going to be printing these out. You're going to be submitting your R Markdown and HTML files. So so it's fine. I can keep scrolling down. That's no issue. Okay. Any other questions? So so it is. I think it's online right now on CCLE. I'll get the solutions for homework 3 up, posted as soon as possible. You guys can start working on it and taking a look at that. Okay. Good luck, you guys. There's no class on Friday. There's a department meeting that I have to attend. So I think section still meets, but lecture. I don't know when your section is actually. Tuesday. Okay. Well, then it doesn't affect you guys. It's the 102. There's a section on Friday, I think. So okay. Well, we'll see you guys. Good luck.